Yeah.
Hello, friends. What does success look like? What is at the helm of success? Well, one can never define success, but let me try. Success could be the co-inventor of 7+ patents, 80 referred publications, being an elected board member of very, very prestigious organizations like the network Berlin-Brandenburg, of IWA or ProcessNet GVC, Dechema, or recipient of the very prestigious award from the Ministry of Science and Technology, BMBF. It is my proud privilege to welcome this success, who is called Professor Dr. Ing. Sven-Uwe Geißen, who's also the professor and head of the Environmental Process Engineering Chair at the Department of Environmental Engineering Technology at the very prestigious University of Excellence, TU Berlin. Welcome, Sven. Welcome to this ECS STEM series with Stalwarts.
Thank you very much for inviting me, Niketa.
Sven, you started your academic journey by studying chemical engineering. Why chemical engineering?
Yeah, basically I started with mechanical engineering.
Okay.
And then during my studies, I shifted to chemical engineering due to the fact that I'm loving fluids. And during my studies, I identified that I'm very much interested in environment, and in particular in water, because I'm, let's say, a waterman. I'm doing a lot of water sports. I was active swimmer. I won a lot of prizes in swimming. I'm an active windsurfer and kite surfer. And therefore, I said, well, I was very much in contact during that time with water, and I observed that water was very much polluted, more and more polluted. And finally, this gave for me the let's say the tension to work, to shift my my profession and professional activities from chemical engineering into water and environmental engineering. So it was very dynamic.
It definitely is dynamic. Coming from you, I can say that so my forefathers come from the desert of Kutch, and Kutch is a desert where we value water. So it really boils my blood when people waste water for simple things like in the household, or when doctors run the tap, or during brushing or shaving, even things, small things like that. And you're talking about really large things. And in today's time, there are so many countries that are running out of water. Cape Town in Africa has no water. Lebanon is in water crisis, South Africa, and so many more countries, and 21 Indian cities have no access to drinking water. So can you explain to us a little bit about water processing, conservation, because a lot of students are interested in studying sustainable environment, the green and the blue economy, as we call it. So what are the different areas and what they can explore to study within this? So there are a lot of questions for you.
A lot of questions and a lot of answers to these questions.
Great.
However, I would like to start with water by itself. And I think we have to be aware that environmental protection in general, not only protection of water resources, starts with ourselves, as you mentioned before. So we have to ask ourselves, do we need the water for cleaning the car? Do we need the water for watering the garden? And we are wasting so much water, which finally has to be processed before you can use it, and we can use it from the tap. So it has a lot of energy consumption, and then directly jump into the question of sustainability. So it starts, environmental protection is also a question of sustainability. And with this example, very easy, very simple example. Water has to be processed before it can be used. That means a lot of energy consumption, a lot of consumption of resources, additionally to the water resources. So that's something which is coming more and more into our mind, into our focus in research, but also in development and application. Yeah, and the processes in general, you ask for the processes. So starting with, so water is, we have a lot of water on Earth. Basically, most of the water is available as salt water. And therefore, we see more and more, as we have an increasing population on Earth, a very much increasing demand in fresh water. And as you mentioned before, it's true. So many people do not have safe access to water, to clean water. It's a demand which is, let's say, very, very much important with respect to human development and the supply of people with fresh and hygienic water. And this finally is basically running in cycles. So we have the rain water, we have the rain, we have the evaporation, we have the use by the humans. And it's not only the population growth, it's also the growth in consumption. Our living standard is leading finally to increase of the water demand. And if you look into the numbers, starting, unfortunately, in the United States, with the largest water demand of more than, as best of my knowledge, more than 400 liters per person a day. In Germany, we are using about 124 liters per person a day as a mean value. And so therefore, we can observe a lot of differences all around the world. And you mentioned the example South Africa, and you can go to Australia, you can go to the MENA countries, you can go to Iran, for example, you can go to India, parts of India, you can go to China, and you will observe water scarce regions. And even in the water scarce regions, so we have projects in Iran, for example, a very water scarce region about 300 kilometers south of Tehran, where no water is available anymore. The river is dry all over the year. And even though people are watering their gardens, it's unbelievable. No? So it's people are not aware of the value of water. And I'm turning it around, Niketa. What is the value of water?
I remember we were together in one of the conferences where I heard a very loud voice from you stating that till the time we do not attach a value to water, people will think it's free and they're entitled to it as much as they want. And I think that is so true because everything starts small. And as you have mentioned the numbers, it's really high. And people get offended when we actually knock on their conscience to tell them that you're wasting water. But if there was a monetary value attached to it, it would be different. Yeah. What do you think?
Yeah. Basically, there is no value. No? So it's an individual value. No? So it's depending. If you are, for example, in the rainforest and you're asking someone for a value of water, the value of water is zero, no? Because there's a lot of rain, a lot of water available. If you're going to desert, no? And you have no water and you're fighting for survival, for drinking, because it's essential, like phosphorus, like other elements which are essential for life. Water is belonging to it. And if you do not have water, you pay everything for water. So the range is from zero up to unbelievable high amount of money which you are willing to pay if you do not have water available for your survival.
You're right.
In this range, we are operating somewhere in this range, and we see, as you mentioned before, dramatic scenes all around the world, in particular the mega cities, for example, but also, as I mentioned before, in the MENA region and in other parts of the world.
It is also said that by 2030, probably there'll be no drinking water in many, many countries, not just cities of the world. And you've also mentioned about water treatment, but water treatment is generally very expensive because it requires expensive filtration and processing media. So what kind of facilities do you envision for developing countries to take up and what could be the measures?
Yes, it's a very important question. So we're talking about developing countries, we are talking about industrial countries, but generally, so we have to, as engineers, we have to adjust the technologies. We have to adjust the technologies which we are applying. So the technology, for example, for sugarcane wastewater is different whether you're treating it in Kenya or treating sugar wastewater from a mill in Germany. That's all, that's clear. And so we have to adjust it, or Brazil, for example. So we have to adjust the technologies to the local conditions, which is not only the question of money, it's also the question of available space, education, the skills of the people, which is very important, and the conditions. So that means the environmental conditions, that means the temperature, the salt content, and so on and so on. So nevertheless, and that's something which we have learned during the last 100 years, we are able to adjust the technologies. So we have had a working group, as you mentioned before, I'm head of a working group, Industrial Water, it's called Industrial Water within the Dechema. It's a very prestigious association in Germany where companies like BASF, Bayer are belonging to. And within this working group, we ask ourselves, what is the impact of climate change to industrial water treatment, industrial water recycling? Finally, the impact is very small, unfortunately, because as engineers, we have learned to adjust the technology. So whether the temperature is higher of the water, we can adjust it. So we have built plants in the Antarctic, we have built plants in the desert, so we are able to adjust it. But finally, and I'm now coming back to the very first point, it's a question of sustainability. So a plant is more expensive if you build it under very extreme conditions, like very cold conditions or very hot conditions. It's more, let's say, energy intensive, finally, because you have to heat it or you have to cool it. But it's technically, it's feasible. That's something for the young generation, which is very important to note, that if we would like to protect the environment, we have to take into consideration the whole life cycle assessment. So that's the life cycle assessment, the sustainability, we call it, and to take into consideration what is the energy demand in order to clean the water to such an extent that we can use it as humans, or we can use it in industry. So, and another important point is what is already existing. It's nothing in the future. It's today existing that we have competition in water use. Competition between industry, between the households and agriculture and the environment. Environment requires also water, and this is only the humans with all the industry, the anthropogenic use. It's also nature which requires water, because we would like to protect the nature, and nature requires water. That's for sure. And this competition, I would not say it's a war, but in some places of the world, it's already like this. But there's a competition, let's say it like this, in water. And we have to clearly identify. So first, also coming back to the very beginning, we have to discuss how to save water and how to make people aware of the value of water and not to waste water. That's starting there. It's basically starting there. And then finally to discuss who will use which amount of water in which quality. No? So there is no discussion in many places about these topics. No? Everyone is doing his own job. And that's something what engineers have to learn finally, also to bring these questions into society, which is very important in order to find a solution for the earth, for the environment, for us all. Because if we are protecting the environment, we're protecting finally also ourselves, the humans.
You're right. Yeah, and you're speaking about sustainability. You're speaking about water and its climate change, its world population, and the excessive use of water that's leading to it. And it's the combination. There are three dimensions to sustainability. One is the economic efficiency. The second is the social responsibility. And the third is the ecological compatibility. When you blend these three things is what comes out. Sven, for engineers, they generally think of water and oxidation. It leads to corrosion and degradation. This is a general understanding. You are part of the very prestigious group, the IWA. Can you highlight a little bit more on the advanced oxidation processes and what does it entail?
Yeah, that's a very special topic, and I do not know whether or not the audience is so much interested in this special technology, because it's a technology which finally is oxidizing substances which we are adding to water. So what are we adding to water? We are adding substances which are biodegradable, and those substances should be biodegraded like it's done in conventional municipal wastewater treatment plants. Mm-hmm. But we have a certain amount of substances like pharmaceuticals. Everyone is using, not everyone, hopefully not everyone, but many people are using pharmaceuticals, but also other chemical substances which we are using, which finally ending up in the toilet somehow. Mm-hmm. And these substances are hardly or even non-biodegradable. And for those substances, we need the advanced oxidation processes, which finally helps us to generate substances which can be degraded finally. Not a complete oxidation to carbon dioxide, mm-hmm. because it's very energy intensive, these technologies. Therefore, we have learned that we have only partial oxidation, which leads finally to biodegradable substances, which can be then treated in the conventional biological wastewater treatment plants.
This is very interesting. You're also part of the network Berlin-Brandenburg. You're the elected vice president. It's a very prestigious position, and the viewers would be definitely interested as to what you are talking about and what the outcomes, or if you can highlight a little bit on that.
Yeah, I think most of the audience might know what are the duties of a professor in Germany, and this is a honorary activity in a, let's say, comparable small association, which is called Aquanet Berlin-Brandenburg. And the intention finally is to bring together researchers and people who are working in companies who are applying such technologies. It's called, let's say, technology, partly from my point of view, it's something like a technology transfer. So we are discussing about projects in research and how to implement them into reality. So we have people who are plant construction, who are applying the technologies, and the same for German Water Partnership, it's the same situation. So I think this cooperation between universities and practitioners and companies is very essential to generate innovation. And innovation is essential for society, and in particular in Germany, in the water sector, I would say, we are in a very comfortable situation, because Germany is spending more than a couple of 100 billion euro per year for water research and development. And what we are promoting now, what we are looking for is to generate more innovation out of this, because innovation finally means application, means earning money out of this, what we are doing. So for my definition, for me, my personal definition is like this: for each and every euro we are receiving from our government, 1/3 is for education, 1/3 is for getting more knowledge, and 1/3 is for economical aspects, for earning money, for generating innovation. That would, for me personally, would be a perfect situation. But the final 1/3 for generating innovation, I would say we have to do a little bit homework, but we're on a good way. And therefore, these associations are very important to bring together, as I mentioned before, to bring together people from research with people from application.
That's really nice how you have explained it. And the tagline of TU Berlin stands that we've got the brains for the future. TU Berlin, which is the University of Excellence, it's very prestigious because it's also part of the Consortium of Excellence with other institutions of higher education from Berlin. So what is that strategy of excellence that you are striving for in that 10 target action plan, which says about network between research and practice that's highlighted by TU Berlin?
Yes, it's a very important question. Also, how to transform, let's say, our research and development into let's say, into a condition where we are generating more innovation. But as I mentioned before, education is also very important. So excellence is, from my definition, it's not only excellent with respect to innovation, it's excellent in education. It's, as I mentioned, it's equal balance, it's balanced education and innovation and know-how or getting knowledge, because humans are always asking questions. No? So that's our driving force. No? So we are looking forward. Our economy is like this. It's a growth. No? So we are growing not only with respect to economy, but also with respect to knowledge. And that's very important. And there are many aspects which are related to this topic, how to implement this, how to improve this. And one of the things is to bring students in a very early stage in contact with the companies. So therefore we have practical training, but that's only one aspect. No? So also in discussions, in conferences and etc. And also in courses. No? So in my courses, each and every semester, I have in every course, I have someone from industry who is giving a short presentation about not only about his expertise, but in particular about his career. So what he studied, what was his career, and what can he recommend to the young people.
So you've opened up a very important topic. Students are definitely interested in knowing that there are going to be real life projects on which they can do internships. And you also mentioned that this is just one aspect. What are the other aspects?
Yeah, so technical universities in Germany stand for, let's say, basic knowledge, really basic scientific knowledge in combination with practical aspects. So building the bridge between basic knowledge and application. So that means a lot of modeling, more and more modeling. No? So that's I think that's clear, it's obvious. Digitization, everything, modeling, digital twins, etc. And combining this with reality. One without other doesn't work in the future. We need both.
How? What are the ways? One is internship. What are the other ways?
Yeah, for the students during the studies, one of my courses, it's the design of plants for environmental protection. So students, it's just starting next week. I can make some advertisement for my course. So it's the design of a full-scale plant. This is a course which is offered at the end of the studies, environmental technology in the master. So it's a course which is where the students can select between different topics. For example, designing a plant for post-treatment of municipal wastewater in order to get it reusable, not to produce reusable water. Another topic might be to design a plant for water recycling at a cruising ship, a cruising vessel, etc. So many different aspects. But finally, they have to make a complete design, including the dimensioning of the pumps, including the dimensionings of the pipelines, including the economic aspects. So what an engineer finally is doing. And I would say at the university is something like a kindergarten. No? So what we are offering is a training. So if they fail, if they're making mistakes, no problems. So we can discuss it and we can adjust it. In the business, in particular, when you're talking about large projects, huge projects, it's more difficult. Let's say it like this in a friendly way. It costs a lot of money if they make mistakes, for example. And therefore, that's part of the training, no? To make mistakes. And that's something which is also important, to make mistakes, but to analyze finally and to accept that you have made mistakes. That's something also which is very important in education, and also a tool to prepare the students for the practice afterwards.
What a brilliant message. The university students, you're equating them to kindergartners, and you are mentoring them and saying that it's important to make mistakes. This is a very profound statement, because students are actually craving for this. Students are wanting an environment which prepares them for the future. And here you're wanting them to make mistakes in a very positive manner, because the more mistakes they make here, the better trained they will be for the jobs of the future. So what are the other facilities that they can expect from this for doing these wonderful projects that you have outlined?
Yeah, and another column is practical training. So we have a lot of bench scale plants, and particular now, so for one semester, we have been not able to offer these practical training due to the pandemic conditions, but nevertheless, very early we started to open our labs again, and practical training is very essential, very, very essential. Not to start the pump and to see how the pump is running, to hear how the pump is running, to hear that something maybe is going wrong, or to watch with your eyes. So we have a lot of digitization, but on the other hand side, we have a lot of senses which are important. Maybe not only the taste with respect to water, but also the eyes. So you can see whether or not water is clear or it's turbid, for example. And you can hear a lot of things, you can smell a lot of things, which is very important, even though we have a lot of digital instruments which are analyzing it. And this is something which we are offering to the students in order to learn this in our laboratories, in our practical bench scale with our bench scale plants, and even within the projects. And that's something which is very important, to combine education with research. I think that's something which is maybe not unique, but it's, from my point of view, which is very important, to combine research projects, application-oriented, not only application-oriented, but also basic research with education. So they are very early involved. So we're offering students jobs, for example, in order to assist very early in a research project, but also a bachelor thesis and master thesis. And sometimes also, as you know, we have a lot of projects running together with industry. So even the jump from university to industry is possible within such a project. No? So if they're starting making their master thesis, preparing their master thesis in a project where industry is involved, we have had some cases where the students finally started their first job in the company, the partner company.
How wonderful. What you're saying is very important. And this could be backed with the very fact that there are jobs in the department, in the university, but also that TU Berlin has a lot of successful partnerships, very, very active partnerships with private sector. And to name some few, there is T-Labs or Deutsche Telekom, there is BASF, there is the Industry and Science Campus of Berlin, Siemens, the Einstein Center for Digital Future, and Mobility to Grid, which is the BMBF initiative. It's at a different campus. So there are 2 campuses and so much more. So this is very, this is pivotal, because the university and the decision makers at the university, like Sven, are actually promoting that. It's just that you as a student or a young researcher needs to have passion to do that and be diligent about it. Right, Sven?
Yeah, completely. So you have to be convinced what you are doing. As I mentioned at the very beginning, so I love water. I'm fighting for water, and therefore you have to be convinced what you are doing. And if you're doing it in the right way, and if you love what you are doing, you will be very professional and you will be successful. You started with success, and one of the major important, from my point of most important, is that you are staying behind what you are doing. That you're doing with love, yes, right.
Yeah, there is an understanding within students, a very general understanding that public universities are always tuition free. But it's also seen that there are some courses at TU Berlin that do cost a fee. Can you shed some light on it?
Yeah, there are a few, I would say a very few. In our system, it's a very complex system in Germany. Finally, most of the courses are for free. You need a certain skills, so they are basically in German language. So that's the disadvantage. The advantage is they are free. We have a very few which are offered in English language, and they cost money, but there's more or less further educational courses. And we are now discussing in Germany how to promote the internationalization in terms of, let's say, we have to be fair because the German taxpayer is financing the educational system. So I think the discussion is going on, and let's see how it will develop. However, my courses, for example, the transparencies are completely in English, and the course I'm giving in German language. So someone who is not so familiar with German, and particularly with the technical German language, and for the German students as well. So because they're working in an international field, they do not work in Germany. Environmental protection means worldwide activity, and therefore it's a basic for German students also to have the, let's say, basics of English language included in the education, as a technical education.
What are the qualities that you would look for an ideal student to win a seat at TU Berlin, considering the very stiff competition that is seen over the last some years now?
You see, there are let's say, two fields. One field is a professional field, which you can make a ranking of different things. Let's say you can see what kind of courses with respect to mathematics, physics, etc. You can read it. What are the requirements? The other point is the human capacities. No? So that means for my team, it's very important to be a team player. To accept other people. As we all know, Niketa, every human is different. No? So, and I'm now 61 years old. I have some experience also with humans, and you too. You are not 61, you are younger, but nevertheless, you have also a lot of experience with people. So our job finally is to identify the advantages, so-called advantages, and disadvantages of a certain person in a certain field. No? And that's depending, and therefore, so human skills are, I would say, are have the same importance finally at the end of the day, not for the studies by itself, because you can go through without having any, let's say, human positive skills. If you're learning, and you can learn a lot of things, but finally you will fail because you are not able to apply it. Because we have to apply it in teams, we have to bring this information to the colleagues, even colleagues without any knowledge about what we are talking. This is something which became very much important, and that's something which I love also with respect to our university. As you know, the Technical University of Berlin has a faculty of human sciences. And someone can ask, what about human science? No, we need human science in order to, now coming back to another point which I mentioned earlier, to transfer what we are developing into society. Otherwise, it's useless. It's useless what we are doing if we do not transfer it, if we do not understand what people are thinking about the technology. Yeah. you know, the first car or the first steam engine, or people they feared about this technology. And the same is somehow taking place right now with different technologies. No? So we have to make this applicable, and that means not only technical applicable, but also social applicable.
Social applicability, transferring it to people, knowledge transfer, all this with your wonderful travels. I personally know that you travel crisscross. Even yesterday you were in Romania, today you're in Germany. You're a great friend of India too. You have, your department and the university has so many collaborations worldwide. Not just that, TU Berlin also has an actual campus in Egypt. TU Berlin also has offices in countries like Brussels, Sao Paulo in Brazil, or New York in America. What does all of these collaborations mean to a student? What can they look for from these collaborations? Is there something in for them?
Yeah, it's also a long story, finally. So looking into Germany, so we have a lot of corporations inside Germany. So between KIT, for example, or University of Duisburg-Essen, or Technical University of Munich. So I have a lot of colleagues where we're exchanging students on a, let's say, a project basis, where a student of Technical University of Berlin is preparing a master's thesis at University of Duisburg-Essen, etc. The same at the European level. No? So we have the Erasmus programs, and I'm responsible for cooperation with an Italian university, University of Brescia, for example. Others. So in Europe, it's no problem. And many young people, many students are spending 1 semester or 2 semesters abroad in Spain, in France, in Italy, etc. And I think that's very, very important. The same worldwide. Vietnam, for example. So we have, and that's related to the projects basically. No? So we have projects, we have had projects in Vietnam, in Hanoi, for example, or in Ho Chi Minh, where from our students, of master students, I think as best as I remember, 3 students prepared their master thesis in Hanoi. So, and the same all around the world. And this is promoted by the offices, this is promoted by our, let's say, general administrative institutions at Technical University of Berlin, which are assisting us in order to do so, in order to get all the papers, to get accommodation, etc., etc. No? So this is something which makes the life much easier for students than before. When I studied, it was not possible to do. It was possible for sure, but with a lot of loss of time, let's say loss of time, a lot of time which you have to spend in order to organize everything by yourself. So it became much more comfortable for the students, and a lot of projects all around the world, as you mentioned before. And again, coming back to the topic of water, water doesn't know any borders. That's the point.
I agree. Yeah, it doesn't know any borders, and it's a necessity for all, irrespective of class, creed, color, religion, whatever. So absolutely. What are some of the key advices or key giveaways you would like to give to the viewers of ECS?
First one is being convinced what you are doing. No? So that you're staying, as I mentioned before, is just you have to stay and you have to love what you are doing, really loving it. No? So I never cared for money. No? So it's we have money, okay, for survival, but finally that's one point. The most important point is that you love what you are doing, and that's one point. And the second point is do it. Yeah. And not stopping. If you're convinced about something, do it. Yeah. And this is something that's also an advice to entrepreneurs, as you might know, Niketa. So don't stop. Make it happen. Make it happen. That's the point. And this is basically all. Not more.
You have already spoken about the whole 9 yards. You've spoken about how you encourage failure because that's the route to success. That's the route to future success in the jobs and the corporates. And to make that happen, you're working day and night to make very successful collaborations, not just with universities and research centers, but also corporates and the industry, not just within Germany, but across the borders of Europe and worldwide, on one hand. On the other hand, you've taken up on yourself to work very hard and sit on these very prestigious positions, but as honorary, so that you can create more avenues for students, avenues in terms of internships, avenues in terms of guest speakership, and avenues in terms of exposure that a student can get, as much exposure as possible, either through research, either through project. And you're also making fundamental changes in the policy where research is included in education, and where corporates, the jobs, the exposure to jobs are part of the education, and failure is accepted and taken with a very good spirit. So this is the whole 9 yards for the student. And students, Dr. Sven-Uwe Geißen did mention that there are programs in English. He said there are little programs, but that's not true. Let me tell you that there are so many programs in German at TU Berlin, but also in English. Some very beautiful programs, like if you want to do an entire MBA in building sustainability, like management methods for energy efficiency, that is possible. Gone are the days when MBA was just very specific. Now it's very theme-based, and that too very evolving. You can be studying global production engineering or space engineering at TU Berlin, and all of these are English medium programs. You can do an entire energy management as an MBA. You could do European and international energy law. He also spoke of energy. You also spoke of knowledge transfer. So these are very, very vital programs. And science of intelligence. This is so interesting because it connects technology and science and people. There are some very interesting programs, not just at the bachelor's, master's level, but also at PhD level, which is the Berlin Mathematical School or the International PhD Program for Computational Neurosciences. Various programs, various options. This entire field was focused on environment, engineering, and water. What can you do after studying all of this? If you're looking to follow your passion and solve the world problems, what are the world problems? I mean, you could be a catalyst to bringing new age solutions to topics like sustainability, water risk management, water resource management, interconnected with very classical technologies for water treatment, sewage disposal, water circulation, and talking about national and international water management. So it's not just within A country or B country, but many times borders. And we know of a lot of water crises. So management, solving issues in drinking water supply. There are so many problems that are coming up. We are not discussing problems, but we are discussing these problems because we need you as an expert to find new age solutions. And there is so much support that we've highlighted given to you. You could be an exponent in drinking water supply or wastewater disposal, hydrology, hydraulic engineering, experimental hydraulics, restoration ecology, biotechnology, river morphology, so much more. Right? In this world of super specialization, there are so many more aspects, and I know you would have a lot of questions. We're always there to answer your questions. Write into us at queries@exponentconsultants.com if you have questions for us, or question for this wonderful stalwart who's carved out time out of his very busy schedule. And it was a lot of inputs. Thank you so much for the wonderful inputs that you shared to our viewers. It's definitely going to help them understand also your attitude as a head, that you're so giving, you've created so many opportunities, and you're still weaving a network of collaboration and opportunities in every breathing moment that you're taking. It has been a pleasure interacting with you. Thank you so much for your time, efforts, and the inputs.
Thank you very much, Niketa. And we stay in touch.
Definitely, yes. This was conversation with Professor Dr. Engineer Sven-Uwe Geißen, head of the Environmental Engineering Chair, TU Berlin. And it was great talking to you. Thank you once again. Bye-bye.
Bye.